Dear student, Assalamu alaikum and welcome back. After a long time, we are here for the subject of biopharmaceutics and we are getting some basic ideas of biopharmaceutics, especially the chapter we have started today. And in the previous our lecture was bioavailability and the bioequivalence concept. Among the bioavailability and bioequivalence concept, we have got plenty of knowledge regarding the methods to do how to calculate the bioavailability and what are the main factors which are affecting the bioavailability studies and the bioequivalence studies. And among those factors, we have already taken some examples, and during our lab preparations, we have already shared data for the calculation of bioavailability by using the plasma method, and the next labs will be for with the continuation of these parameters, and we will get some information and some knowledge about the bioequivalence studies. Today are going to another important topic of our calculation of the bioavailability parameters. The main thing we have how to calculate the concentration of drug from plasma or urine or some other parameters which we are using in the case of pharmacodynamic approach and the other. So today we will learn about the analytical method. Analytical method. Analytical method, this is not a new term for all of you, because this type of the method is important or the necessary for the calculation of the drug concentration from the plasma. Analytical method are basically those type of method which are used for the estimation or the calculation of the amount of drug from the plasma. We will use different instruments, different techniques to complete this process of the analytical method. The analytical method of the each drug is already reported in the literature, and because we are discussing with the bioavailability and the bioequivalence drugs are the basic for those type of the drug which are already in the market. Now, when we are considering the analytical method, it means the drug is already proven, and now we are just calculating its amount within the body or within the site of at the presence of at the site of action, and its rate. So in case of analytical method, we can use different instruments. One is HPLC, other is spectrophotometer, and same case GCMS, and same case UHPLC, and same different instruments we will use to validate the method. First of all, for example, we want to use HPLC method, so we need some parameters and some requirements. So in case of analytical method, in case of bioavailability and pharmacodynamic approach, studies must be valid for the accuracy and sufficient sensitivity. There are the different parameters, different techniques, different ways to validate the method. Analytical method, if present in different books, first we will and we want to calculate the bioequivalence in our labs, we will develop our own, because the conditions may be different. In some conditions we can change. We have a change of the instruments, change of the mobile phase, change of the column, change of the other conditions, say composition of the mobile phase and other things. In case when we use the analytical method, it means we have to focus on the particular area. Either the analytical method is present or we have to develop. If we have to develop, then we will have to change some measure some limitations or some conditions. What are the conditions which we have to fulfill when we assume that the analytical method is good or not? We have to calculate the accuracy of the method, precision, sensitivity, specificity, and robustness. Okay, in case of accuracy and sensitivity, we will assume that how the method is accurate. How can we check? Remember, for the sake of analytical method, we will first choose, if we taking the example of HPLC, we will have to choose the mobile phase. We will have to choose its column specification. We will have to see the instrument information, temperature, and the temperature conditions, flow rate, then retention time, LOD, LOQ. These are basic steps we will have to remain in our mind when we want to develop an analytical method for the calculation of concentration through plasma or urine or some other materials from within the body. We will have to check if the mobile phase is already developed and reported in the different literature, different books, then we can use the same composition of the mobile phase. Mobile phase is basically a mixture of some organic and aqueous bases and aqueous solutions. It may be buffer or with the methanol and the acetonitrile. It may be water, methanol and the acetonitrile. These are all they have the different compositions of the different ratios of the organic and the inorganic substances. Column specifications. Column specifications are basically the specification of the stationary phase, because HPLC stands for high performance liquid chromatography, and we want to perform the liquid chromatography. And in the case of chromatography, we have the two phases. One is the stationary phase and other is our mobile phase. Stationary phase are basically present in the column, and mobile phase is the liquid which is flowing through the column. When we have a specific amount of the constant value of the mobile phase, and we will get the more specification of the column, then we will move toward the instruments information. Because when we see a literature or the books where the analytical method of the particular drug whom we want to calculate the bioavailability is present, we will check, okay, HPLC method is present, so we will repeat in our lab. If the results are same, then we will assume that the method will work, or we have to make some little changes in the developed method. But in case of those drugs which are newly discovered and we want to make its bioavailability studies, and we have no any type of the specification, and we have no any type of the information in the pharmacopoeia, so we will have to develop those methods. For the sake of development of those methods, we will have to apply all these conditions. We will check the accuracy, precision, sensitivity, specificity and robustness. Temperature condition. So if the drug is more, in the basic phenomena in the case of HPLC and the liquid chromatography is the solubility of the drug or the active moiety with the mobile phase, its affinity. That when the drug, in the case of, and these solubility have the different, we can say the different factors, and among those factors, temperature is the one. So temperature conditions should be in our mind. In which condition, in which temperature we have to check a particular concentration. Flow rate. Flow rate means the movement of the mobile phase toward from the stationary phase. Now remember, in case of HPLC, we will have to make some solutions, we will have to make some dilutions of the drug, and these dilutions will be applied on the HPLC instruments, and by the running the mobile phase on the stationary phase, we will, from the column, we will predict the concentration but through the detector, and this type of the flow rate will be mentioned. Either it is 1 ml per minute, 2 ml per minute, 1.5 ml per minute, 0.5 ml per minute. This flow rate is very much important. Say retention time. Retention time is basically, for example, we have seen a method, analytical method which is reported in the literature. The retention time is, for example, 3 minutes of the peak. So when we repeat it, we have got 3 minutes. If we have a method, if we have the same parameter, same mobile phase, same column, same instrument, same temperature condition, flow rate is same, and we want to check the retention time. Either we have a specific retention time or not. The main thing when we want to change some changes in the analytical method is we want to squeeze or reduce the retention time, because the method where the retention time is 15 minutes, and if we develop those methods whose retention time is 3 minutes, it means we have save our money, save our mobile phase, and our method is maybe so much accurate as compared to the previously reported. So what we are learning today, we are learning that and at what time we have to make some changes in the analytical method. Analytical methods are present in the literature, but we have to make some modifications according to our ease and according to our available facilities. Okay, in case of LOD, it's limit of detection. And in case of limit of detection, we have to calculate, okay, how much our method is accurate. Either we have a minimum amount of LOD and LOQ, limit of quantification, limit of detection, limit of quantification, retention time, flow rate. These are all the parameters which we have to be in our mind when we want to develop or we want to make some changes in the already reported method. Okay, now come towards our point. Say we have considered all these things. We have considered the mobile phase specification and instrument, temperature conditions, flow rate, retention time, LOD, LOQ. Then we will move towards our accuracy of the method. If our method is accurate or not, we will have to make some different concentrations. We will have to make some dilutions. For example, we will make 100 microgram per ml concentration of the drug, 50 microgram per ml, then 25 microgram per ml, then 12.5 microgram per ml. Say we have makes 4 different concentrations, and we will apply these concentration by using the mobile phase, column, and these specification into the HPLC system. We will got peaks, and that peaks will be give us 3 different areas. Okay, remember how we calculate the estimate of the amount of the drug by using the HPLC. We can use the 3 different ways. Remember, first of all, we want to make a standard curve, because in case of each and every method, either UV spectrophotometer, either HPLC, either UHPLC, or the other instruments, GCMS, we have to first of all construct a linearity curve. And how we will construct a linearity curve? Linearity curve can be calculated in case of HPLC by 3 different ways. Remember, dear students, for example, I have this peak by using the HPLC. So I have the 3 different informations. One information is peak height. So I can make a graph between peak height and concentration. These are as we increase the concentration, we will got the more height of the peak. So our one standard curve or the linearity curve may be in case of HPLC is between the peak height and the concentration. Okay, another way is peak width. peak width. So from this point to this point, peak width. Now we will make a graphical presentation between peak width and concentration. As we increase the concentration, we will got the more width of the peaks. So another way is peak width versus concentration. And the third and most applicable is peak area. So we will assume that this is the area which is covered by the peak, and these values are will be provided by the instruments. This is the peak area. So we will construct peak area versus concentration. As we increase the concentration, we will go to the more peak area, and we will get the standard curve. Okay, what we are studying today? We are using the analytical method. We are using the validated analytical method. And the validation of the analytical method may be possible by using the concept of accuracy, precision, sensitivity, specificity, and robustness. Question is, whom we have to apply all these parameters? We will apply by using these techniques. They are the composition of mobile phase, column specification, instruments, temperature conditions, flow rate, retention time, limit of detection, limit of quantification. Okay, and when we want to check, okay, our method, our reported method is accurate or not, or the reported method which are present in our literature is accurate or not, or the modifications which we are creating in the reported method is accurate or not, we will have to check the accuracy. And in case of accuracy, what we will do? We will make the different concentrations, dilutions, 100 microgram per ml, 100 ppm, 50 ppm, 25 ppm, and 12.5 ppm. And we will apply these samples into the HPLC, and we will get some peaks. These peaks will be, the concentration of these peaks will be calculated, and we will check, okay, when we apply the 100 microgram per ml, and if we got 98 microgram per ml, say 50 microgram, we got the 9.1 microgram. In case of 25, we got 25, and in case of 12.5, we got the 12 microgram per ml. These are the concentrations which we are assuming, which we have prepared, which we have make the dilutions from the stock solution, and these are the concentrations which we have calculated by using these three methods, from one of the three methods, either by calculating through the peak area versus time, either by the peak width versus peak area versus concentration, peak width versus concentration, peak height versus concentration. Among them, we have to construct only one curve. That curve will be the standard curve. Okay, by taking the standard curve, we will check, okay, how much concentration we have getting back by applying the method. This is the values which we have prepared by ourselves. These are the results which we have calculated by using the linearity curve. Now we will calculate the percentage RSD. And percentage RSD will be calculated by taking the three values of this and this, by taking the mean, and after taking the mean, we will convert it into the our standard deviation, and then we will have to check, okay, how much the concentration is variated from our prepared or the reported concentration. This type of the calculations will give us the accuracy of the method, how much accuracy we have using this. And same case precision, and in case of precise, we will check how the method is precise, and then we will check, okay, how the method is sensitive. There we will calculate the LOD, limit of detection, and LOQ, limit of quantification. Limit of detection is basically, we will apply these different minimum concentrations, and we will get some peaks. When we apply the 100 microgram per ml, we will got some peak. When we apply the 50 microgram, our peak will be reduced. And when we apply the 25 microgram per ml, then peaks will more in small amount. Then add the minimum value where the peak is now available and minimum peak is available. Then we will say this is limit of detection. means limited amount is rejected now. And what is limit of quantification? Quantification is the peak area which we are getting by using the different calculations. So limit of quantification and limit of detection are the more important parameters where in case of sensitivity, where we check, okay, either we have our method is sensitive or not. So specificity and robustness, these are basically those parameters where we want to check create some variations. For example, we are getting these results by using the mobile phase, methanol and water. Then water and methanol, 1:1 ratio. So we will make some changes. We will change the ratio of the water and methanol, and then we will check, okay, and same we can change the composition of the nature of the column, and we can change some temperature condition change. These are basically the robustness. And after getting the satisfactory results of all these parameters, we will say this method is now validated, and this validated method will be used for the calculations of the bioequivalence studies. So in case of bioequivalence studies and bioavailability studies, we will have to move towards our accuracy of our instruments, validation of our method. Our method is validated or not. If our method is reported in the previous books, previous literature, it means we can apply, but first of all, we have to check this method in our environment, because when the developed method is reported in the pharmacopoeia or in the books, it is reported multiple times, different scientists, and then this document will be are the part of the pharmacopoeia. But before this, when we are using in our environment, these environment may be changed, or some other conditions may be changed. Okay, these are all the parameters which I have told you in mobile phase composition. Remember, when we discuss with the plasma, things will be little bit different. First of all, we have to take some plasma. Remember, in case of bioequivalence studies, we will take samples at the zero order, zero time. Zero time means before applying or just after giving the oral drug in case of bioavailability studies. And these plasma are the plasma which we have taken from the patient or the volunteers. We will use to make some composition, some dilutions, just like this one, 100 microgram per ml, 50 microgram per ml, 25 and 12.5 microgram per ml. We will play all these parameters by using the pure plasma rather than the mobile phase. But we have to reconstitute the amount of drug. What we will do, we will first take the drug and the plasma. We will make a solution of the drug in the plasma, and then we will apply this plasma into the HPLC. But remember, we cannot apply these direct plasma onto the HPLC, because there are some proteinous substances in the plasma, and these proteinous substances may block our overall system. So we have to first extract the amount of drug. Okay, I will move towards how process will be performed with the plasma. We will take, say, 20 ml of plasma, and this plasma, and we will make some concentration of drug. In case of drug, we will have to make some say we have a plasma and we have used some amount of drug into it, and these drug molecules will be mixed, and now it's a mixture of the drug and the plasma. Say its concentration is 100 microgram per ml. We can make some dilutions of 50 microgram per ml. We can make the same composition of plasma, 25 microgram per ml, same 12.5 by taking the dilutions just like in the case of mobile phase. Now, either we have to apply take the some 20 microliter or the 50 microliter and inject it to the HPLC system, or we have to make some changes. Answer is, we have to make some changes. We have to make some, what type of the changes we need? For we have to make, first of all, to extract the amount of drug from the plasma. For the sake of extraction, for the sake of removal of the pure drug from the plasma, we will make some process of deproteinization. Deproteinization may be performed by applying the deproteinizers. And deproteinizers are basically organic solvents. Organic solvents, among them dichloromethane, among them methanol, diethyl ether. These are all the organic solvents which may be used for the sake of deproteinization. Okay, how we will make a process? We will take a concentration we have prepared in the plasma, and we will add the 1:1 ratio of, say, 1 ml this mixture, drug containing plasma, plus 1 ml. Okay, when we dissolve the 1 ml of the drug concentration, drug containing plasma, and plus 1 ml DCM, dichloromethane, which is deproteinizer, it will make some mixture. And after first of all, we will vertex it, it's an instrument for the sake of mixing, and then we will make centrifugation. After getting the centrifugation, we will have two layers. One layer is at the bottom, and the one upper layer is the clear. The upper layer is the clear layer of the organic solvent, the deproteinizer, dichloromethane, diethyl ether, methanol, the material which you have used. The material deproteinizers are selected on the basis of the solubility of the drug. If the drug is more soluble in dichloromethane, then we will use the deproteinizer, the dichloromethane. And if the drug is more soluble in methanol, then we will use the methanol as a deproteinizer. Okay, we will take the supernatant, and this supernatant will be maybe applied directly or maybe make another change. Means, first of all, we have taken the supernatant, the upper layer, and then we will dry it. And after taking the dry, we will have a same, just like a test tube, and then we will apply mobile phase into it and make a mixture. After getting the filtration, we will apply on the HPLC. Remember, this is some changes in case of plasma. When we are discussing the amount of plasma, a measurement of the concentration of drug through plasma, or making a standard curve by using the plasma, the concept is little bit different, because there is the addition of the deproteinizer. Why we are adding the deproteinizer? Because deproteinizers are basically deproteinize the proteins, and these proteins may be excluded, and the concentration of drug which are present in the plasma may be extracted. Same case, same process we will perform when we take some samples from the volunteers. You know, in our bioavailability studies, we will have to apply for example, we have given making the two groups. One group is given a drug A, and the other group is given a drug B. And when we take some blood samples from the volunteers, and blood samples should be taken at the different time intervals, these blood samples are converted into the plasma, and now these plasma have some amount of drug at the different concentration. Now, how can we apply this plasma on the HPLC? We will first move with the same parameter. For example, we have assumed that concentration which are present at the 30 minutes, which we have taken the plasma from the volunteer, is 100 microgram per ml. It means we will have to extract this 100 microgram per ml from the plasma by using this technique. We will use the amount of the plasma which we have taken from the volunteer add some debutanizer and then make a mixture, and making this mixture we will convert into the vertex first, then centrifugation, and we will take the two layers. One layer is our plasma protein layer and other is the organic solvent or the debutanizer layer. We will separate the debutanizer and then debutanizer maybe make some dry, and getting the dry we will add some mobile phase here. This is mobile phase, and mixing some mobile phase we will apply on the HPLC after getting the filtration. This will give us the peak. Remember, our method should be so much accurate because there are no any type of the impurities will be available. And in case of bioequivalence studies or the biological studies, validated method are those drugs which are getting metabolites. Remember, we should know how much metabolites may be occurred of the specific drug, because in case of metabolites we will get not only a one peak of the in case of HPLC system we can get the two peaks, and one peak is our metabolite and other is our actual drug. So the knowledge of the drug will be especially particularly for those who are principal investigator, who are discussing, who are conducting the study, is so much accurate, and knowledge of this method, accuracy of the method, analytical method should be so much important, because this method is ultimately used for the calculation of the drug. If this method is wrong, what will happen? Very simple. Our calculations are our assumptions, our amounts which we are assuming that getting from the plasma of the volunteer is wrong. And if we have the wrong amount, wrong concentration, it means our AUC, Cmax, Tmax values are wrong, and ultimately we have no any direct concept or the accurate idea of the bioavailability studies. So this method is so much important for the calculations of bioavailability studies. We have to get some knowledge regarding, first of all, whom the drug we want to take the bioavailability studies. Either we are using its metabolite or not. If we are taking if the drug is converting into its metabolite, then we will have to first convert into the we have to convert first check its metabolic concentrations, and then we will discuss the other conditions of the drug. I hope you understand this, the application of the analytical method. And analytical method for the measurement of the drug must be validated for the accuracy, precision, sensitivity, specificity, and robustness. The use of the more than one analytical method drug a bioequivalence study may not be valid. Remember, if we are using in the bioequivalence studies one method, and on the other way we are using the another method, then it's maybe not applicable. Why? Because each and every method have some limitations. So only one method should be used, and because the different methods may yield the different values, data should be represented in both tabulated and graphical forms for the evaluation. The plasma drug concentration time curves for each drug product and each subject should be available. This is all about analytical methods, which are the basic requirement of the bioavailability and the bioequivalence studies. If you have any questions, then you may ask me in the comments of the video. Thank you.